Now, in the lesson I had mentioned before, we said that when we do graphing to try to determine where two lines might intersect, if you don't have graph paper, and if they don't really intersect on the grid lines, then you have fractions, and so it could be a problem. So are there other ways? And the answer is yes. And the first other way we're going to look at is the other way called substitution. And in substitution, what we do is we solve for one of the letters, like we have here, y. So we say y is actually 2x. So we rewrite this first equation, 2x plus, now notice y is 2x, so we're going to put that 2x, we're replacing the y, that is substitution, equals 16. We now have a variable that's just one variable, group-like terms, and we find that x equals 4. So if x equals 4 here, we go 2 times 4 is 8. And that would be then our ordered pair, 4, 8. And the method we used was substitution. Now, I'm not going to do them all, but I'll do the odds, because otherwise it gets quite tedious. And I'm here to show you the method. Now here we're saying that x is this, so where the x is, I'm going to put that. 3y minus 1 plus 2y equals 14. So I group like terms, and I get 5y. Transpose this, and I get 15. And I get y equals 3. So here I've gotten the y this time. So now I put the 3 where the y is. So 3 times 3 is 9. 9 minus 1 is 8. So for number 3, that's my ordered pair. And if you'd like to try any of these, here's the answer for 2, and there's the answer for 4. And keep in mind the answer key is in the back of any additional exercises you've downloaded. In number 5, again, the x's solved for. So this is the value of x. We're going to put that where x is, which is what I've done. Got rid of the parenthesis, group like terms, solve for y. Y is 2. Then if y is 2, I go over here. 4 times 2 is 8 plus 3. X is 11. Now that's 6 if you want to give that a try. And 7 now, we have run into the situation where this is in standard form, this is standard form. We haven't solved for x. So I'm going to transpose the 2y over to the other side, and then I get this for x. Then in the other equation, I put that for my x. This is the process of substitution. I distribute, group like terms, and I get a negative y equals 0. Well, this is a case where positive y equals 0 too. So my y coordinate is 0. So I then go here. If y is 0, x equals 7. There's my other coordinate. And for number 8, you'd probably have to get rid of the fractions here first and then solve for x. Here x equals y plus 8 after you transpose. And they're done in a similar fashion. So for number 9, we have to solve for one of the letters, x. Transpose the negative 2y, becomes this. We then put this in that other equation where x is. Clear parentheses, group like terms, transpose. We get 7y equals a negative 21. Divide both sides by 7, y equals negative 3. If y equals negative 3, 2 times negative 3 is a negative 6 plus 2 gives us a negative 4. Now I'm doing number 10 because this one is a little different. So I will transpose the y, and I transpose the 4, so I get this. This is the value of y that I'm going to substitute into this equation. For the y, I'm now going to put this value. So I clear parentheses, I combine like terms, and I end up with, wait a minute, now this is 8 equals 10. Now that's not true. Okay, why I chose this one is when you end up with a not true statement, there is, for number 10, no solution, because these lines are in fact parallel, so there would never be a solution. Alright, let's go on. Now in number 13, again another little different twist here. Here's my value for y, which I'm going to put right there, and I distribute, and I end up with this. Now notice these, when I group like terms, just cancel out, and I'm left now with this statement: 15 equals 15. Is that a true statement? Yes. When you end up with a true statement, then that is, for number 13, an infinite number of solutions, because these are the same equations in different forms. If I multiplied here everything by 5, you'd see there, and then put them in standard form, you see they are exactly the same equation. Now for these others, again, this one would be an untrue statement, so they're parallel lines, no solution. Here we get a couple with fractions, and here is the same equation, just disguised a little bit, and so an infinite number of solutions. Let me do number 16 for you. Okay, so the first part was quite easy. We're just going to transpose the y over. So we have x equals y plus 3, which we then put in the second equation. I get rid of my parentheses. I group like terms, subtract 18 from both sides. I get a negative 5. Divide both sides by 10. I get a negative 5/10 that reduced to a negative 1/2. I then put the negative 1/2 right here. So the opposite of a negative 1/2 makes it a positive 1/2. I transpose that to the other side as a negative 1/2. I convert the 3 to 6 over 2. Subtract the 1/2 from that, and I get 5/2. Now I went quickly with this, but I did check my work, and went over it to be sure I had it accurate. Whenever you get fractions, it's always more of a challenge. Now, as we read through this, notice we have a formula y equals this and y equals that. So we have these two formula that are in essence both equal y. So in a sense we're saying y equals y. So I put this y here and the other y there and solve that equation for x. X is 30. So that would be $30 a ton. And I then put the 30 where the x is and go 3 times x and get 90 tons. That would be equilibrium. Okay, we kept this under just about 11 minutes. Not too bad, but we didn't do them all, but you saw the process. I don't have to do 20 examples. Maybe we're doing too many.